Hi out there. I hope you're doing well on this beautiful day. So today, guys, what we'd like to explore is using statistic to make decision. Okay. So my name is Rakubu. I'll be taking you through how we can use statistics to use decision. Arrive at some conclusion. Great. Let's see what we have. But before we do that, what I'd like you to do, how do we really make decisions on a daily basis in your own life? Have you ever thought about it? Do you make decisions based on what your friends think, what they think at home? How do we really make decisions? Sometimes, yes, we might use history and say, oh yes, I remember this because of this and this. That's actually using data when you make decisions that way. But big corporation and government, we make decisions by collecting data, analyzing data, and arrive at some conclusion. That's another form of decision. How do you use decision on your own? Think about it. Do you just randomly make decisions? Okay, let's see. So now let's define what is volatility and how do we really measure volatility. What is volatility? Volatility is actually risk, or you might have had this usually in finance or from stock market. They'll talk about volatility. It's randomness. It's if, let's say, the rand. Today the rand is 15 rand to $1. Suddenly it changed to 17, 18, all the way, and it changes rapidly. We'll say the rand is volatile. Okay, because it's deviating a lot from average over a period of time. It can be daily, can be within an hour, just moving. Okay, and we do have commodities which are volatile. Some of them are things like oil. They're very volatile. You know, the price is not that fixed. You might know the price is, let's say, 100 rand now, but tomorrow when you check the price, changed. You check within an hour, the price has changed. That's volatility. Okay, it's a high deviation from the average. And how do we measure volatility? Volatility, we're talking about the deviation from the average. Okay, so another way we can measure volatility is by using the standard deviation. And remember, standard deviation is the average, but it's a special average, which is the average deviation from the mean, which is the average. Okay. Remember, let's say I have your marks in a class. Student, you got 30%, 40%, 60%, and so on. And the average for the class is 55%. Then, how far are you from the average? That's the standard deviation. Does that make sense? If the class average is 55% and your mark is 60%, you're 5% deviated from the average. You're above by 5%. Okay. So standard deviation is all those deviations for each and every learner in that class. Are we all together? Fantastic. So now, what I'd like us, we're looking at decision making, and we're going to look at problem favorite crepes flavor. We'll solve that, and smoking among young people, and we'll look at an investment problem. After an investment problem, we'll look at performance between two classes. Okay. And decision making, guys, you can actually study, which is a new thing, called decision science or operation research. And actually, there's lots of study that actually World War II was won by decision science. By optimizing resources. Okay, so some countries will optimize resources during World War II to win the war. Actually, there's a loss that World War II was won by using decisions. Okay, so decision science, it's a big field which you can study, also known as operation research. Okay, so we'll look at also at the projection, the number of coronavirus deaths in South Africa. Okay, so what is decision and what is statistics? I mean, for me, decision might involve a bit of thinking about what available options, and from available options, you choose one. I might want to buy banana or apple, and you make a decision and say, based on what? So sometimes it might be based on cost, even though you want it. But finances might force you to take that kind of decision. Doesn't mean what we want. Sometimes circumstances will force us to make that kind of decision. Okay, but now in statistics, when we make decision, we try to, we'll look at mean, average, all those kind of things and arrive at some conclusion based on that. Okay, that's another form of making decision. Then, what is statistics? Statistics is a study of analyzing data and representing data also. And from there, we still arrive at conclusion. It's the same as decision, but made using statistics and data. Okay. So the two are kind of related in a way. Now, what are we going? Let's look at some of the keywords, which is volatility and return. So volatility, it's a low volatility, it's a lower deviation from the average. You know, the movement is not that rapid, but where volatility is high, the movement is rapid in a way. Okay, I'm not sure if you've seen the stock market. If you look at those graphs, the more they like movement, the volatility is high, and the less noise, the less the volatility. And what is return? When you talk about return, okay, and I'll use that word when we look at an example in investment. Return, we're talking about when you invest money and you earn interest, you make a return on your investment. Okay, that's what we're talking about. So let's start. We said we'll look at the favorite crisp flavors, smoking among young people, investments, performance between classes, and the projection, the number of coronavirus deaths. Let's look at that. Now let's start. Which age group are at greater risk of requiring hospitalization or dying if they are diagnosed with COVID-19? Can we calculate the average age of people at high risk? Can we calculate the people at high risk from dying from COVID-19 or being in hospital? Okay. Let's look at how we can calculate that and then arrive to some conclusion. So, this is the actual data collected. And if you look at this data, it's grouped data. So if you look at this, this is number of deaths from there. So what does this indicate? The graph showing number of coronavirus deaths in South Africa in 2020 by age. 0 to 9 years, only 3. This does not mean the whole year, but this implies maybe it was a week or 2 weeks or probably a month. Okay. 0 to 9, we had 3. 10 to 19, 5 deaths. And 20 to 29, 26. 30 to 39, 116. 40 to 49, 244. And we can see that 50 to 59, which is 471. And 60 to 69, 506. Can you see that 60 to 69, that's the highest? Okay, those are where we get most of our death from COVID-19. So we'll call that a modal class. It's a mode, the most occurring. So that will be the modal class. This will be our modal class. Then you go to 70 to 79, it's about 342, 80 to 89, 161, and 90 to 99, which is 45, unknown 11. What does it mean? Unknown, we don't know their age, okay? How does that happen? How can we not know? We know that 11 people died from COVID-19, but we know their age. We don't know their age. It's possible that they were in the hospital and no identification or something like of that nature. But we still have the statistics for that. And this is the total people died from the COVID-19 for that period. How do we calculate the average? We're going to take this grouped data and put in the what? Frequency table. And remember that the frequency table will put the age, the frequency. Frequency will be how many people die from COVID-19 per class interval. And when you talk about class interval, we're talking about the age category, which is 0 to 9, 10 to 19, and so on. Let's do that and see how it looks like. We're going to take this, put it in the frequency table. So, which age group are at greater risk of requiring hospitalization or dying if they are diagnosed with COVID-19? We can calculate the average age of people at risk. Let's see. How are we going to estimate the average? Because if you look at the table which was published by the government, I think, we don't have the raw data. What do we mean raw data? The actual age, we just have the groups that between 0 and 9 is only 3. So we'll have to calculate an estimated mean. Are we together? Using the data. Okay. So to do that, an estimated for the mean can be obtained by assuming that each of the raw data takes the midpoint values of the interval in which it has been placed. For example, to calculate the mean, it will be the sum of all frequency, are we all together, multiplied by the midpoint over the total number of frequency, which is that mathematical, which is F times X. X is the midpoint, F is the frequency, and this is the frequency which is over the total frequency. Okay. So what are you going to do? We want to know how many people died in each age group interval, which is the frequency. Then find the midpoint. The midpoint is halfway of the age interval, multiply by the frequency. Then from there, we'll calculate the mean. Okay, so for now, we're going to take a short break. When we come back, we'll do the actual calculation. Then let's make decisions from there. I hope out there, guys, you're not just observing only. You need a pen and paper to do your mathematics, okay? And remember, never give up. And it's okay not to understand. We just have to persist and put effort. It's okay when I look at a problem and I say, I have no idea. What is important is what do we do when you don't understand? I think it's to seek help and it's to keep working hard and being consistent. That's the most powerful thing. Great. See you after the break when we do the actual calculation.